and welcome to the webinar about clean code. I'm very eager to do this session, and I was very happy to see that we had over 200 of you sign up within 36 hours of the announcement. For that reason, you've all received an email that we split the webinar into 2 groups, and we will host the webinar twice. That means that we will repeat the webinar again in 4 hours, which will be 8 p.m. here European time and 2 p.m. EST. And of course, as you are used to from us, we will put the recording on the YouTube channel. So before I start, let me please quickly introduce myself for those of you who don't know me yet. My name is Mark Rummel, and I've been involved in Navision for over 20 years. I'm a teacher with NAV skills, and I work as a product specialist and evangelist for a company called 4NAV from Denmark. I've been writing a few books, and I'm very passionate about what's going on in the community. I think, honestly, I have the best job in the community since I get to help people get better at their job. And I've lost count of the amount of companies that I helped with things like performance tuning, reviewing code, and lately moving solutions to apps and app source and 365. Right, so in the last 2.5 years, I've trained more than 700 developers across the world with design patterns from Reykjavik to Toronto and Tokyo to Bangkok, but of course mostly from Denmark, Germany, Benelux, and UK, and wherever the majority of the Navision is still happening. So let's get started. Let's dive into clean code. And I know that many of you think that this session, sooner or later, will end up talking about extensions. And let me start with terminating that. Extensions, in my opinion, have nothing to do with clean code. They are just in a way an invention by Microsoft to formalize the way that you should have developed anyway. Think it's more for sales guys and sales managers, because since we have extensions, everybody is talking about clean code and decoupling your code from NAV, right? So that's a good thing. Unfortunately, on top of this, extensions v1 comes with a bunch of silly rules. They cannot be modified after deployment and require weird upgrade routines, but they are mandatory to use when you want to create an app for App Source. But did you know that, in fact, if you look at the way that Microsoft has really implemented behind the scenes, it would have been easier for them to just use FOPs. Anyway, this session is not about extensions. In fact, the only good thing about them is if you want to buy a Navision add-on, you should ask a partner if they ship as an extension. And then if they say yes, you know that they did not do any hacks into the product, and they should not have done anyway, and you can ask them for the FOB file, right? So this session is about clean code. And why is clean code important? Before I can start even explaining what clean code is, we should first explain why it is important. And I will try to explain to you in a way that you can even explain to someone who doesn't understand programming, computer science. And actually, I used one of my customers as a guinea pig this morning. It's CFO of one of my customers. He doesn't know anything about programming. And I tried to introduce to him the terminology technical debt. And technical debt is an invention first mentioned by Ward Cunningham, a brilliant guy that we owe a lot of good things to in our computer science community. He was also the one who started with design patterns way before the Gang of Four even started to do anything with it. So technical debt is when you compare your code to financial debt. If you buy something and you buy it on a credit card, or you take a mortgage on something, then you know that eventually you have to pay off your debt. And if you don't do that, the interest will just accumulate. And then after a while, you will just realize that all you're doing is you're paying off debt, and you don't have any money to spend on real things. And with technical debt in computer programming, it's kind of the same thing. You start with some code. And we all know that when we first start programming, we never really completely have the true complete picture, right? Nobody really knows when they start programming that, okay, this is the goal, this is what we want to get at. So whatever you do as a programmer, you just code in such a way that with the information you have today, you create the best code. But then you get more information and you look at the code with the new information and you're like, if I look at this code with the new information, I should have maybe programmed it in a different way. And if you don't clean up right away, you will know that after a while, it will be just harder and harder and harder to get things into the code. And after a while, if you don't refactor the code with new information, you will spend more time, or it will be almost impossible to add code because you constantly are looking at this spaghetti, or maybe not even spaghetti, but you're just looking at this code and say, okay, how I'm going to add this, right? How I'm going to do this. And within the Navision community, for a very long time, we had this mentality that said, if it's not fixed, if it's not broken, we don't have to fix it. And many developers, including Microsoft developers, fear that when you start cleaning up code, which is called refactoring, you start breaking stuff and it will cost money. But the opposite is true. Refactoring is the only way to pay off for technical debt. And even though we already started with a metaphor, let's make it even more clear with a metaphor, right? So you probably recognize this building. Everybody recognizes this building. This is the Louvre in Paris. And I was here a couple of weeks ago with my oldest daughter. You should know that the Louvre was first built in the 12th century and later moved in the 16th century, which makes it basically the oldest part of the building is 500 years old, right? So the question is, how do you get into this building, right? How do you get into the compound? Well, to do that, you have to go through these gates that I actually grabbed a picture from Google Maps, and you have to go through these gates in order to get in with your car or with your vehicle or walking in, right? And they are not that big. If you can see here with the picture of the car, they are not that big of an arch, right? So what were these arches designed for? Are they designed for cars? Are they designed to handle the massive amounts of tourists that we get into the Louvre these days? Well, I was there, right? It's designed for horses and carriages. And for a time when not a lot of people were rich enough to have horses and carriages, and they were not queuing up to get into the Louvre. So how did I get in, right? I was there a couple of weeks ago and I took a selfie, one of my first selfies. That's a great thing about having a 13-year-old daughter and taking her to Paris, that you're actually going to learn to take selfies. We took this bus, right? You can see how huge this guy is. It's 2 stories high and you can sit both up and at the bottom, and this bus has to go through this tiny little gate. And the guy who created the gate 500 years ago, he didn't know that we were going to use big buses to get in. And if that guy had to pay for all the minutes or hours that this bus has to stop and go slow, because this bus has like an inch at every mirror to get in, right? So it has to slow down every time it tries to get in. And it would be just more efficient to have a bigger gate so the bus doesn't have to stop every time it has to get in, right? So how does this reflect in Navision? Navision is not 500 years old. In fact, it's much younger. But the first version of Navision was built in 1987, making it 30 years old, which is in computer science like 300 years, right? And although Navision was updated a number of times when we moved to DOS to Windows, from native to SQL in the early 2000s, and more recently we moved from a 2-tier architecture to a 3-tier architecture, and we introduced the rotated client concepts. But we never really looked at the original application architecture. The first 2 conversions from DOS to Windows and from native to SQL were simply done by doing a backup restore. And then when we moved the 2-tier code to the 3-tier code, we just used some conversion tools that converted our forms to pages and reports to RDLC, but we never really looked into the code and said, well, is this really how we should program in 2010 or 2012 or 2014 or when whatever you converted your code into 3-tier. And currently, you know, Microsoft is working at a new IDE, going to leverage Visual Studio Code. Next week, we'll have a webinar where the great guys like Waldo and Ian John and Eric Hogarth and Daniel Limelswan will explain to you what the status of that is. But you can guess what we get, right? I mean, you can guess what Microsoft is going to give us. Of course, we will get a conversion tool, and then your manager will come to you and say, here is the conversion tool, and you can convert your 3 decades old code that was first designed for DOS, and now you can convert it to VS Code. But is that really a good way, right? Is that really the way that you want to do that? Because what is Navision designed for? What was Navision designed for 3 decades ago, right? Navision was designed to be implemented and customized with a short communication line between the partner and the customer. When I started with Navision, which makes me feel old, but Navision promoted a regional sales model when I started. That was before they invented verticalization. You had to find your customers where you lived, which was lovely because you never were stuck in traffic queues. Because programmers were already hard to find even in 1987, the IDE and the application code was optimized to be easy to read for non-programmers, such as accountants. And they could very easily make changes without doing stuff like breaking the data model and consistency or even worse things, right? It was very hard to break Navision. And we have this whole community now with people that if you ask the average Navision developer, how did you get started? The majority of us will say, well, we started as an end user, or we started as an accountant, or I was a mechanical engineer, or something like that, right? Essentially, the same application code is now used for a cloud application. But in a cloud application, there is no direct link between the partner and the customer. And with the move from the Seaside IDE to Visual Studio Code, we start expecting professional programmers who studied programming at a university to start making apps for this, right? So welcome to Dynamics 365 for Financials, which you all know behind the scenes is just Navision with the same architecture as 30 years ago, right? So let's go back to clean code, right? Let's have a look at the definition of clean code. I've done a whole lot of research for this webinar and before that, and I found one that I found most appealing. This is, again, Ward Cunningham, and this is when Robert Martin asked him a question, what do you think clean code is? And his answer was stunningly simple, and the answer is always true. Clean code is writing code in the way that people expect. And that makes code that you wrote with Navision 30 years ago clean code, right? But it doesn't mean that the same code you wrote 30 years ago is clean code. In fact, let's move back to Paris and let's move back to the Louvre. The architect that designed those arches where now a bus could hardly squeeze in, if that architect would told the French emperor to make those arches bigger because in 500 years we would have buses, the French emperor would probably have burned the architect as a witch, right? That's what they did 500 years ago. So it's a good thing that we don't do that anymore. We're not going to burn the guys that built Navision 3 decades ago. But the same is true for Navision. The application architecture is perfect for the model that it's designed for, but it was just never designed for the cloud, right? So which one of these two castles, which one do you think is more flexible? The Lego castle can be rebuilt into anything else. It can be built into other models. It can be expanded and mixed with other models, but it requires some skills. Most of the skills are self-explaining, but yeah, there's people who can't handle Lego and then you get ugly models. The other castle is knitted, right? And it cannot be changed, or at least it's very hard to change it without considerable effort. You can add other knitted items, like a knitted house, but it's not so flexible anymore. It's basically like taking the Lego castle and glue it together so that nobody can change it, right? And Lego is probably the most frequently used comparison that people use with Navision because it came from the same country and it has building blocks and what have you, right? So let's look at some Navision code that has been with us for a while, and I hope you get some audio. If you don't get audio, then you should pretend that there is audio, and the audio is like this smooth little music that's getting from nice to worse. Right, so let's see if that actually works. Anyway, right, so I hope you got the sound. It will make it a little bit of a nicer experience if you have sound, but anyway. How did we as a professional community end up with 5,000 lines of code and call ourselves professional, right? What happened? And the answer to that question is actually amazingly easy, right? It just doesn't expect a lot of things. So CodeUnit 80 is a bad example to analyze, right? But it's very good for the dramatic effect. I actually stole the idea from Robert Martin, who does the same with one of his presentations with Java code. The problem is much easier to explain if we look at some recognizable piece of code that has not been changed since Microsoft acquired Navision. This is Navision code. This is not Microsoft code. The resource journal post line. This is probably the code unit that I use in every one of my classes, right? This code unit really has one function. It's called code, right? And it just has a bunch of global variables. If I switch from PowerPoint to NAV, and I'll switch to the correct database, you can see that this code unit 212, this code unit just has one function. The function is called code. You can call into this function with the run with check and in the unrun trigger, and this function just does a whole bunch of stuff. And then we have this tiny little thing that has been added later. And if we look at this code, we have a bunch of global variables, right? Everything is global, which is the thing we loved with Navision when we started. Everything should be global, right? So is this clean code, right? Is this clean code? Yeah, I think so. I think this is clean code. If you look at the definition of clean code is writing code in a way people expect. I think this is code which was clean from 1987 to 2011. I think something happened in 2011. Something happened around that time frame. And it was not partner-ready software, although it was in the same year that we started to talk about design patterns in Navision and started this whole movement of clean code and reusable code, right? Let's look at the same code unit in a better structured way, and I choose to display it in Visual Studio Code because that's what we're going to get, and it's going to make us more productive and more professional. You can in fact download this example from my GitHub. If you go to github.com/markprommel, it's there. It's probably the largest VS Code project out there. It has like 200 Navision objects that you can use and play around with. It's much bigger than the Navision example codes. You can see here that I broke the code up into pieces to make it more readable. If not, test near, then test far, isolate transaction, find last entry number, create or update register, and then create entry. Right? Everybody can use it, can read it, has local variables, only left the globals in there. So what do we need in an IDE to get this? What is the primary thing in an IDE that we need in order to code like this, right? I think some of you will get it, right? We need go-to definition. And when did we get go-to definition? We programmed for 25 years, and some of you still do. Some of you still program without go-to definition because you still have customers running on classic client on old versions and they don't have go-to definition. Every now and then I'm doing these code analysis and people ask me to RDP into their system, and I find a system that doesn't have go-to definition. What do you do when you don't have go-to definition? Right, you have to go into the variable, you have to go and check if it's a local variable or a global variable. That's why some of us invented this horrible Hungarian notation where we have LREC and GREC, and then we go and X out of the object and go into Object Designer, and then we find the code, and then we read the code and we say, oh, and then we go back to where we came from, right? We need go-to definition in order to be professional programmers, right? So how can we get here, right? Can we actually recognize bad code? And can we recognize if code is bad and if it has to be updated, right? Because we have programmed like this for such a long time, and we have been converting and updating our code, right? Well, for this we have invented code smells, right? Code smells is something that you can read about a lot online. But not everything you read online can be applied to Navision, right? So let's quickly browse through a couple of code smells. The first one is cyclomatic complexity. Cyclomatic complexity is a very simple algorithm where you take every if statement and you just look at the if statement and you just say, okay, well, in order to update this, I have to make it more readable. Right. The second one is number of code lines. How did we come up with this rule? How did we come up with a rule of number of code lines? Right. This rule was invented for terminals. My first year as a programmer was not with Navision. I programmed a year in COBOL. It was very, very interesting to learn to program from someone who did that since 1964. The poor guy almost gave up on me. In COBOL, you don't have that many lines, right? And you want to get an overview. And in COBOL, you don't have Alt-Tab to tab into a different program. So this is when we invented this number of lines, right? And somebody will say you need 100 lines. Somebody will say it's 20. Somebody will say 50 or 80. And I don't like this code. I don't like this rule. I mean, it's a good rule, but so many exceptions, and if you go into VS Code, you can just make the font small and everything will still fit on one screen, right? So, but it's a way, right? I think we can all agree that having a 1200 lines in one function is not a good thing to do. Number of variables. This is another one, right? How many variables should I have in my code, and especially record variables or code units? Well, first of all, I think that you should not have any code units in your variables anymore, and actually think that in my demo I'm going to hopefully sell you on a different concept of working with that. But it's a way you can say that if you have too many variables, your code smells, right? This is a slide that I stole from Waldo. I think he showed this slide at NAV Tech Days, I think. Just cleaned it up a little bit with a nicer font. We use global variables. Why do we use global variables in the Navision community? It's an interesting question. Why do we use so many global variables? And again, the answer is so easy to find. The DOS version, and I have never programmed in a DOS version, so maybe there's someone in the audience now that will stand up and say I'm wrong. But the DOS version, for what I've learned, does not have local variables, right? So the Navision started off with only global variables, and we converted that code. We converted code that only had global variables, and we converted that code from DOS to Windows, and we continue to program like that. In fact, even Navision continued to program like that. It only took them, like, I think Microsoft started using local variables. If you look at new application areas like workflow and assembly management and cache management, there we have local variables, right? But for a long time we kept on using global variables, and we have this confusing community that, yeah, but we have to use global variables because that's what people expect. No, we have to get rid of that. It's a code smell. right? So we have a whole bunch of code smells, and we can go on like that. We can include commits. We can start talking about Hungarian notation. But I want you to forget about all of this. Not completely forget about all of it, but forget about it for now, because I think we can find much simpler rules to work with. I would like to introduce the solid design principles by Robert C. Martin. If you have not seen any of his videos, if you've not read any of his books, then that is what you will do tonight. Thing number one, cancel your Netflix subscription and start watching this guy's videos on YouTube. Go to Clean Code, listen to the words of a wise man. And you will probably pick up a thing or two about Java on the way, because that's what he is using in all of his code examples, right? So SOLID is an abbreviation of abbreviations, and SOLID stands for Single Responsibility Principle, Open Close Principle, Liskov Substitution Principle, Interface Segregation Principle, and Dependency Inversion Principle. We are already 25 minutes into this webinar, so you can kind of guess that we're not going to have time to talk about all of this. The solid design principles are invented for object-oriented programming, right? But that does not mean that we cannot apply them to NAV. I mean, what have we learned from partner-ready software? We learned from the principles that the principles for object-oriented design apply to NAV as well. In NAV, we also want to keep the data and the business logic together, and we want to loosely couple our business logic. Yeah? So every one of these principles can be applied to NAV as well, and I think every one of these principles should at least have a webinar like this. But today we're going to start with talking about the single responsibility principle, right? A class should do one thing, and a function should do one thing. And if you apply this single rule, if you apply this rule, an object in NAV should do only one thing. You will find out that none of the other rules matter anymore. None of the other rules like cyclomatic complexity or any of those things like number of variables, they don't matter anymore. Because if an object in NAV only does one thing, and if your function only does one thing, then what is the cyclomatic complexity of that function? It's not going to be 10 or 12. It's going to be 1 or 2. Every if statement is indented once, and if an if statement goes into a complicated loop of code, then the code will be a function by itself, right? And this should start applying, I think, to tables and code units first. I think if you apply this to tables and code units first, you will find that the rest of the objects will follow, right? But I hear you. I mean, you're not in the same room. You're probably chatting in a chat window, and I can't see it right now, but anyway. Objects cost money, right? We have to pay for objects to Microsoft. And this is another one of these silly things that we inherited from the past. Right? Why do we have to pay Microsoft money to have clean code? It's a ridiculous rule, and that we have to get away from this, right? You can CFMD your solution, and then you have to repeat yourself, but customers don't want you to repeat. Customers want to have a customization, and for a silly customization, they have to pay for tables. What if I tell you today that we can get around it? What if I can tell you today, and I will demo it to you, what if I can tell you today that from now on, from this moment on, you can have clean code for free? You can have as many objects in NAV that contain clean code, and it will be absolutely for free, and you don't have to pay Microsoft to get clean code. So hopefully that will make that you get something out of this webinar. But even if you don't like what I'm going to show you, and I know that some people don't like it, even if you don't want that, and even if you want to stick to the old way of coding, I think the return on investment of buying 10 code units to do 10 things is huge. It will make testing easier. We'll talk about test-driven development in a moment, right? But your code is just going to be easier to test and easier to maintain and easier to upgrade, right? So implemented this solid design principles leads to a whole list of anti-patterns that is so easy to find in Microsoft's code, right? Management code units, all these code units that do multiple things. Adding a type field to a table that is included in the primary key that makes a table do multiple things. Application area, hacking into one page to make it look like it's 2 pages, right? And most of all, code cloning, right? Navision is just full of code cloning. That is a habit that we have to get away from now that we have started to learn this clean coding mechanisms, right? So let's take a typical example of code in Navision and see if the solid design principles are implemented. And one of my favorite examples is format address, right? Format address code unit. So let's start by asking the first question. Is this code unit doing one thing? Well, yes, it only does formatting of an address. Really? Look closer to this code unit, right? This code unit has a function for each table in the database. And if you look closer, you cannot even add new ones, since extensions has this limitation that you can not add functions to code units or override existing code, as if it's too dangerous for us to have a sharp knife, right? We would cut ourselves, right? So I can hear you ask, so I have to create a code unit for each of these functions? No. There is a much easier way to solve this puzzle. In fact, we are going to end up deleting this code unit completely and replace it with something much more flexible, much more generic, much more upgradable. And while we are at it, let's also make it easier to work with extensions. That will make Microsoft happy as well, so everybody ends up being happier. So we are going to refactor. Why not? Right? You see this code and you think, oh, this is wrong. Yeah, it works, but it's wrong. We don't code like that anymore. And if we don't clean it up, or if I clean it up, everybody will start benefit from it. So how many times have you looked at code and thought, I'm going to refactor this? And then you look at it again and say, nah, I'm not going to refactor it. And the reason why you are not refactoring is because we are afraid of the code, right? We don't own the code owns us, because we are afraid that if we refactor it, it will change us and we will introduce a bug and it will haunt us. Why do we have this fear of code? Why? We shouldn't be afraid of the code. Coding should be fun. That's why we all started to be developers in the first place, because we had this experience, one of making something work, and we want to have that feeling again. But we are afraid of this message, right? And this message is unpredictable. This will improve with VS Code. In VS Code, you will not get this message at compile time. In VS Code, you will get a list of compile errors, and it will help you. VS Code is going to allow us to have the next level of professionalism in our community, right? Refactoring should look like this. We should be happy, and it should be a fun job, and we should be going home proud of our job, knowing that we have saved many hours of aggravation and we made our application more clean. We will have paid off the technical debt. We have paid off interest. We can use our credit card again, or maybe we can even start saving up some money so we don't have to debt in the future. Paying off debt is always a good thing, right? The answer can be found in test-driven development, right? And this is a discipline that we lack in our community. Not only partners. I mean, I think I can count the number of partners in my classes that use test-driven development on one or two hands, right? Maybe the big ones like LS Retail, or the MVPs, right? Like the company that Luc van Vught is working for. Not even Microsoft is fully leveraging the testability framework. I say, yeah, they do. No, they don't. Yeah, but they have test code units. Yeah, they have, right? But they only cover 40% of our application. And covering 40% of your application is just not enough, right? Recently, Waldo published a long list of functions that he found in Navision that are not called from anywhere, right? Functions that do nothing. And if functions do nothing, they should be removed. And that's what the testability framework will help you do. Testability framework will help you find these boat anchors. Testability framework will make sure that you're comfortable deleting code because nobody is using it, right? So let's see how we can do that. How can we start refactoring and how can we make it feel safe? Refactoring is nothing more but implementing a test that you trust with your life. And then you change the code a bit. You run the test. It still works. You change the code a little bit more. You run the test. The test still works. Then you change the code a little bit more and it breaks. And you put it back and you start figuring out what you broke, right? So today I want to show you a very, 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 very simple example of this. I have a whole bunch more examples that maybe we can do in another webinar or something like that. But the goal of this little demo is to hopefully inspire you to start doing this, right? And I've had many, many, many discussions during the workshop with partners that customers don't want to pay for the testability framework. You should not charge your customers for the tests. You should quote the customers the same amount of time that you quote them today. And then you start using test-driven development. And I can guarantee you that you will find that you will be finished quicker when you implement test-driven development than when you don't. Because you will create clean code and you will create code that contains lesser bugs. And if you change a bit of the code at the last moment, you don't have to go through Team TFS to check in the code line by line. You can just check in the code because you know it works, because you use test-driven development. Test-driven development, that's the last thing I want to say about it before I go into the demo. Test-driven development cannot be confused by making the Microsoft test run on your own code. That's a fine thing to want, but implementing the Microsoft test does not test your code, right? Test-driven development means that you write tests for your code. The Microsoft test framework takes hours to run. Do you really think that you can do refactoring with a test framework that takes hours to run? You need a test that runs within a few microseconds, so that every time you change a line of code, you can actually run the test code, right? So let's go into the demo and let's switch databases. We will do this demo on the Azure preview that we have for the VS Code environment. And we're going to refactor this, right? So we have the code unit format address. We're going to refactor this code unit. If I collapse all of the functions in this code unit, you will see we have a long list of functions. Typically what we do as a Navision programmer, we start adding code here, right? But we cannot do that anymore because we have to use extensions. And we want to clean it up. We first want to make sure that all these functions, that they are not required anymore. We want to go back to the core of the code unit, which essentially is this. The extension of the code unit is this and this. This is all the code unit should be doing. Format the address, and there's a little helper function to generate the postcode in the city. Right. I actually always use this example. I always use the same example to teach people clean coding principles. And sooner or later, you're going to hit the guy who created this code unit, right? That's what happens if you have an open source community. So it happened to me as well. I did a training in Denmark, in Aalborg. Actually, we'll go to the same place, to Aalborg, again later this week. I went to Aalborg and I did a training, and I mentioned this example. And I had the guy in my class, and he created this code unit. So I was like, oh my God, now I made a worst enemy in life. But funny enough, he agreed with me. He said, well, Mark, actually, I created this code unit. The first version I created was only these 2 lines of code. But then I took it to my manager, and the manager said, No, that's not how we program in Navision. All the functions should be in the same code unit, right? That was clean code in 1996, or something like that. So how do we refactor this code, right? How do we change this code unit without breaking stuff? Well, the first thing we do is we write a test. This test is just a silly example, and Luc van Vught will probably shoot me for writing tests like this, but I just wanted to show you a very simple example, right? I'm going to create a new customer because I don't want my test to depend on the Microsoft test data. So I'm just going to quickly create a new customer, and then after creating this customer, I'm going to read it again from the database. And then I'm going to use the format address function to format the address, and I know that my first element should be the name, the second element should be the address, and the third element should be the concatenated value of the city and the postcode. In this case, in North American format, because, or Great Britain format, in UK format, because this is a UK setup database, right? And then if we get something that we don't expect, we throw an error that the testing address was unexpected. So I'm not using all of the testability framework from Microsoft. I'm simply going to wrap this into a test runner. The test runner will allow me to run this test in test isolation mode. And test isolation means that the data will be rolled back after the execution, right? So I'm going to execute this test runner. I'm not going to execute my test. If I execute my test, the data will be in the database. And if I execute my test and the data is in the database, this test will fail in the next time, and I don't want that. I don't want my data to preserve in the database. So I'm simply going to run my test runner, and now I'm going to do that, and Navision will say it's a success, right? And this is what I expect, because I haven't changed anything yet, because I have not started to do any refactoring, right? So what is the first step, right? The first step is probably to start moving these functions away. If I go to this code unit, I have these functions here, and I don't want these functions to exist in the code unit, right? So the first step, and I've actually prepared this, I think you don't want to see me type all of this code. So I actually prepared this to as a FOB file. So I'm just going to import this into the database. So the first step I've done is I have made a change to the customer table. And in the customer table, I have added a global function. And this global function is formatting the address of the customer, right? So now I moved the business logic to the data. This is object-oriented design principles. The data and the business logic belong together. But I hear what you say. I hear what you say. This is a change to a Microsoft object. Why are you changing Microsoft objects, right? Well, I have some good news for you. In VS Code, you can make this into a table extension. In VS Code, you're going to be able to add functions to Microsoft tables without changing the footprint of the Microsoft code, right? So it's, again, a huge benefit that's going to allow us to do more modern development, but it's going to require us to refactor our code. So let's go back to the test code unit. I'll just filter on changed objects here, and let's look at the test. The test has changed just a little bit. The test is now changing if this function actually returns an address, right? So let's run the test and see if we broke anything. Let's run the test runner again. And we can see that, yep, everything is still working, right? So far, so good. Everybody's happy, and I can still format addresses. And this is actually step number one. This is something that you have to do. But still, if I go into my code, I can still see that my customer function calls into the customer function. And the idea is to get rid of that, right? I don't want to have this function anymore, right? So I have proceeded to the next step, and the next step is to actually change the code. I've changed the code a little bit to go directly into the format address function, right? So if I now go back to the customer table, I will see that the format address function goes into format address doing format address. This is where Hungarian notation may be useful, right? So many format addresses here. So here we have format address, and format address just goes directly into the main function, right? So if I implement this, let's run the test. Let's first run the test. So now we will run the test. Let's run the test runner, and it should still work, right? Still works. So now we should be able to go to the code unit that we just changed, and we should be able to go in and delete this function, right? Don't do this in your customers' databases. This is Microsoft code. You should never do this in a customer database. It's just an example. So we run the test runner again, and yes, everything still works, right? So we can now format an address without having this function in the code unit. So we can do this for every table. This is going to be some work, but after a while you will end up with the code unit probably looking something like this, right? The one that we had before, where we end up with the code unit having just this, right? This is already cleaner code, but I'm not happy yet. I'm not completely happy. I'm not completely happy with this code. The reason why I'm not happy with this code is that this code is very rigid. It's not easy to change. The function has a fixed set of parameters, and still if I want to go in and if I change this guy to name 3, I still have to change all of the implementations of this code, right? So how can we change that? How can we change the behavior? And the answer can be found in implementing argument tables. Let's go into the next FOP. I think we were with step 4, right? This is the ultimate goal that I want to achieve. So let's go into force and let's add this code. If I now go in, and if this is going too fast, you will just have to go to the YouTube and look at it again. But if I now go in, I have a table here. The table is called address format, but this is not really a table. This is a class. This is a collection of data with behavior. And the collection of data is the fields that we need to format the address. But we're never going to use this table as a table. This table is never going to contain data in the database. I actually asked Microsoft if they could change the table type list to also contain temporary table or class or something like that, something that would prevent this table from even existing in SQL Server. And then this arguments table has a method, format city, and then this guy should be a local. It should just be a helper function. So what I can do now is I can go back to my customer table, and in my customer table I can change the code. And of course the penalty of doing that is that I have to populate the fields first, right? And in this case I've used a nasty trick. I've used transfer fields. You can see in my address format table that the field numbers have the same signature, but you can go wild here. You can use reflection or one of the polymorphism patterns that you can find on the web. You can actually start reverse engineering the table and use recref and fieldref to find the fields and what have you, right? But now I'm just populating the format table, and now I'm just throwing in the format address table, right? So let's go back. We can actually delete this code unit. We don't need this code unit anymore. And now we will run the test, and everything still works, right? So what have we learned, right? What have we learned from this? We have refactored. We have refactored using testability. We have actually enriched our test vocabulary. We also have created some documentation, right? Because if I look at my test code, this test code is documentation for anyone who wants to know how to use this feature, right? This test code unit becomes documentation of my APIs. This test code unit is going to explain how the API for formatting an address is going to work, right? No, let's not go into this slide just yet. This table will never contain data. this table is always going to be empty. When is Microsoft checking if this table exists in my customer's license? Microsoft is only going to check that if I write data to the SQL Server database. As long as I do not write data to the SQL Server database, Microsoft is not going to check this table against the customer license. And this is not an accident, my dear audience. This is not an accident. This is by design, right? Microsoft is not going to charge you for tables that you are going to use as a class to write clean code. So this is a perfect way to start writing clean code. This is a replacement for a code unit. Not always, not always, not always, please. Don't start replacing, and there's a whole bunch of loopholes because you can't use record variables, and there's a whole bunch of things that you can't use. And I would love Microsoft to make this a more official pattern, and maybe we can do that once we get rid of the fact that we now have 2 compilers, and 2 compilers is never a good idea. So this is free code, right? I can start writing free code, and Microsoft is not going to charge me for any objects, right? I can give this table to a customer. There's actually one caveat. There's one caveat. This table has a function, and in some versions of Navision, this is fixed in the latest builds, but in some versions of Navision, you have to go into your code. In some versions of Navision, you have to explicitly change this to a temporary table. If you don't do that, you will still get an error that the table is not in your license. It's a bug. It's a bug, and it's been filed to Microsoft, and Microsoft fixed it because argument tables should be free. Okay. So this is an interesting graph. We have so many smart people in our development community. This is a graph by Martin Fowler, and he actually drafted a graph of the technical debt. Everywhere in this graph where the blue line is different from the red line, we have technical debt, and maybe in the first time it will feel like you're going fast because you start with nothing, you start with clean code. But after a while you will start getting slower, right? After a while you will go into the situation where it is so hard to get new code in. And in fact there is one simple rule. If a customer asks you to do something and you look at the code and you're like, ooh, this is going to be hard, refactor the code until it's easy. Refactor the code until it's easy to get it in. And then you will solve 2 problems. The code will be easier to maintain in the future, and the customer is going to be happy. And I can almost guarantee you that the amount of time that you will spend on solving it is going to be the same as trying to hack this question into the existing code, right? So what have we learned today? First of all, extensions are not guaranteed to have clean code. Events are a perfect way to obfuscate bad code. We'll just throw in 40 events in code unit 80 and then it's clean. No, it's not clean if you throw in 40 events. Navision was designed way before we had any decent development environment, and I think it's time for refactoring using the solid design principles, right? So call to action also for Microsoft, please. Move your solutions to Visual Studio Code. Write tests, lots and lots of tests. Analyze your technical debt and start refactoring. Otherwise, you will get into the situation where you're in code lock. You cannot add any code to your system anymore without breaking stuff. So with this, I would like to end. We have 5 minutes for Q&A left. We've done amazing on time, right? Ideas for future webinars? Maybe we could do more on refactoring. Maybe we should do something on open and closed principles. Luc is going to do a webinar again on testing in NAV. And I think dependency inversion is also nice for a next webinar, right? So hopefully none of you left before this moment, because this is the time for Q&A. You can see the URL to my blog here, markbrummel.blog. Couldn't find an easier URL. This is my email address and my Twitter handle. very active on Twitter, love to tweet to people. So with that, let's go into Q&A, and Rick, maybe you can help me answer some of the questions.
Sure thing.
Okay, so we have a bunch of questions. Let me organize my dashboard here to get a better overview of this. Why does the question panel always end up being so small? Will there be a recording available for later view? Yes, we will put this on YouTube. I will show you our YouTube channel. This is my YouTube channel. If you go to youtube.com/user/BrummelDS, you will find all of the videos. If you go to the playlists, there will be a playlist with NAV skills webinars. We have 4 NAV webinars. I actually have a list with videos by Robert Martin that I really like that you should watch. So this is a good place to start watching these videos. Rick, do you have better luck with this silly question panel?
We have no questions.
We have no questions. Oh my. Well, then I guess if nobody stands up and raises a question, then we can close the webinar. Going once.
Oh, here we go.
How exactly? That's very good. How exactly does it save time to refactor the example of format address? It appears getting rid of all functions just takes a lot of time, even though the functions will hardly be ever changed. Yeah, that's always the penalty of picking an example which is easy to understand. So in this case, the refactoring of the format address is probably not going to be a perfect example of something that you would do in real life. In real life, you would focus on the application areas that change most, right? Doesn't make a lot of sense to start refactoring code that doesn't change very often. I would start with changing these pieces of code that change all the time. Actually, when I do my workshop, we will refactor some posting routines, which makes more sense, but it will take more than an hour to get through that, and we don't have time for that today. So it's a good question. So format address is probably not the application area where you would start. Ghostbird said thank you. Well, you're welcome. Any other questions?
Maybe we should try the 3, 2, 1 thing again, Mark.
Yeah, maybe that helps. Well, anyway, yeah, there's going to be another one, I think, or is that just my answer windows? No, it's my window that's playing with me again. Okay. Well, thanks for attending and hope to see you again in the next webinar. Next week we have the VS Code webinar, and the week afterwards we have a webinar about testing. So thanks.
Thank you all. Bye-bye.
Bye.